Welcome to up to date class. Today we learn about the exponential growth. So what is exponential growth? In the dictionary point of view, growth of a system in which the amount being added to the system is proportional to the amount already present. The bigger the system is, the greater the increase. So now let us start the learning process of exponential growth. So what is exponential growth? Exponential growth is a process that increases quantity over time. It occurs when the instantaneous rate of change of a quantity with respect to time is proportional to the quantity itself. Now we look about some example, some growth like this is observed in real life activity or phenomena, such as first we look about the growth of a bacterial colony. The growth of a bacterial colony is often used to illustrate the exponential growth. Also, we can see the exponential growth pattern in the virus infection, when the virus spread in a community, which is also often illustrated by this growth pattern. This is called exponential growth. Or the growth of debt due to the compound interest, it is also follows some kind of similar pattern. There are very lots of example who follows the exponential growth. Now if we look some mathematical point of view, what is the mathematical expression of exponential growth? And it is very important to identify the mathematical criteria of exponential growth. So now we try to understand the mathematical consequences of the exponential growth. We look a expression that called x equals to a into b to the power t. Here we consider t as a time and x is our quantity of some things. It is called quantity, q quantity, and here a is a constant term. It is clear that a is a constant term. Let us consider a equals to 2 and b equals to 3. Now we find out some values of some values of x for the given value of t. For this we can draw a bar here, value of x, and here value of t. For values of t equals to 0, values of x equals to 2 into 3 to the power 0, that means 2. Values of t equals to 1, 2 into 3 to the power 1, that equals to 6. Values of 2, we get values of x equals to 18, and so on. So if we consider values of t equals to n at the time nth time, we get the value of x n equals to 2 into 3 to the power n. So this is the final value if we try to calculate the values, and we see that the values of x is rapidly increase, and its rate of increase is defined by this t, and t is in the power of b, that means in exponent form. That's why this mathematical pattern explain the exponential growth. I think it is mathematically correct. Now we delete something so that we can see some graphs of some exponential growth pattern, and for this we delete some things. Look at these graphs. Here the graph contains 3 curves. Clearly the red curve is represent the linear growth. Why we call this is a linear growth? Because this expression, this is represented by 50x, and f of x equals to 50x. That means y equals to 50x, and we can say 50x minus y equals to 0. That means this is an equation of straight line which is passes through origin. Next, the blue line represents the cubic growth, because here the blue lines, that means y equals to x cube. So this is explains the cubic growth, but the green line it explains the exponential growth, because here y equals to 2 to the power x, and x here in the exponent form of 2. That's why it's called the exponential growth. So these are the curves, and these are the expression, and these are the representation of exponential growth, cubic growth, linear growth. Now let us know something about the Malthusian growth law. So what is the relation between the exponential growth law and Malthusian growth law? Formally you can say that the exponential growth law of a population, it is the Malthusian growth law. So why you called the Malthusian growth law? Now because there is a great economist and philosopher. There was a great economist and philosopher, Thomas Malthus, who is known for his population growth philosophies, and who is noted for the Malthusian growth model, founder of the Statistical Society of London. So what is the Malthusian growth model? And Malthusian growth model based on some things, and it is essentially exponential growth based. Clearly here written that exponential growth based. Therefore Malthusian growth law is exponential growth based on the idea of the function being proportional to the speed to which the function grows. That means if we write in mathematical form, we can see that dn dt equals to Rn, where n is the population size, and R is the intrinsic growth rate. R is the intrinsic growth rate, or we can say that this is the proportional constant. We call it proportional constant. So this is the thing that Malthus proposed. If we find out the values of the population size at a time t, after some time left from the initial size, then we have to calculate the values using integration, and for this we have need some original values of initial population size. Let us consider n0 equals to a is the initial condition. Now we can integrate thing. Integrating, we get dn by n equals to r dt. After integrating, we get ln n equals to rt plus c. Now here given that n0 equals to a, that means this is the initial conditions. So for t equals to 0, we get ln equals to a equals to 0 plus c. That means c equals to ln a. Now from these we can find out the values of final population size at the time of t. That means ln capital N equals to rt plus ln a. From here we get ln capital N by a equals to rt. That means capital NT equals to a into e to the power rt. So therefore after time t, from the initial size, population stage, after time t, if we find out the population size nt equals to a into e to the power rt, and here t is in exponent form. Therefore this is the population size exponential growth model, or called Malthusian growth model. It is widely regarded in the field of population ecology as the first principle of population dynamics, with the Malthus as the other founder. Now we look at some graphs that's called human population growth curve, and you can see that this axis expresses the time and this axis expresses the population size in billions. And after 18th century you can see that clearly how the human population in the world growing like this. So this is the exponential this is the criteria, this is the character of exponential growth, and generally the curve look like this and exponential form. And you can recently show that the exponential graph when coronavirus spread out in the whole world, the quarantine or lockdown phase was started, and in some limited time period the spreading rate of coronavirus is looks like. So there are various example of spreading or increasing things who follows the exponential growth rate. And I think this video, this tutorial will help you to understand the concept of exponential growth and what is the exponential growth model look like in population biology, was invented by Malthus. So thank you very much for watching. If this video helps you, please like and subscribe and share this with your friends. Learn and enjoy. I will see you in the next video.